Assalamualaikum and hi, I am Nur Akila Beti Ma'asim from Group D6 and I'm going to represent our summary of lab report, Computerized Grating Spectrometer. Abstract. In this experiment, the objective is to determine the wavelength of the colors in the spectrum of mercury and cadmium discharge lamp. Spectrometer are used in many fields. For example, they are used in astronomy to analyze the radiation from the astronomical objects and deduce chemical composition. The spectrometer uses a prism or a grating to spread the light from a distant object into a spectrum. From example, we can conclude that for mercury light, when wavelength is 542.40 nanometer, the discrepancy is 2.34%. When the wavelength is 515.82 nanometer, the discrepancy is 1.00%. And when the wavelength is 411.50 nanometer, the discrepancy is 13.37%. For cadmium light, when the wavelength is 820.38 nanometer, the discrepancy is 54.79%. When the wavelength is 627.87 nanometer, the discrepancy is 20.74%. And lastly, when the wavelength is 609.24 nanometer, the discrepancy is 36.91%. So from here we can say the theory is the light produced by an electric discharge in a rarefied gas of a single element contains a limit number of discrete wavelengths, or we can say an emission or bright line spectrum. So the pattern of the colors in an emission spectrum is characteristic of the element we are going to use, which is the distance between the lines is called the grating line spacing D, and the path length between two adjacent light rays differ by one wavelength lambda and also the angle theta. From here, the relationship between them is lambda equals to D sin theta, whereas lambda is the path length between two adjacent light rays differs by one wavelength, d the grating line spacing, and theta is the diffraction angle.
Good evening, Doctor. My name is Kala Devi Ana Perempuan Anbanandan. I'm going to present my part for experiment 20S6, which are methodology, data, and results. For the methodology part, it will start like this. Set the spectrophotometer next to the mercury vapor light source. Mask the light so that it narrows beam to the collimating slits. Once warmed up, we align to get a clear image. I'm only going through this briefly. Then set up rotary motion to high resolution and the sample rate at 20 Hz. Later, select graph display. The vertical axis must be light intensity, however the horizontal axis must be actual angular position. Set the room to be dark. The spectrum will be examined closely. Brightest among the first to order spectral pattern will be determined. Use the gain switch to record data. This is the data obtained for mercury. This for cadmium. And our result is mainly on finding discrepancy value between the values obtained from experiment and the theoretical value. This calculation is for the mercury. Again, mercury. These are for cadmium. That's all from me. Thank you.
Hi and Assalamualaikum. My name is Nur Aisha binti Muhammad Daud. For 2O acid experiment, I will be presenting the discussion part and conclusion part. For the discussion, in this experiment, The wavelength of the colors in the spectrum for a mercury vapor light for the first, second, and third line obtained are 411.5 nanometer, 514.82 nanometer, and 542.4 nanometer, respectively, while the theoretical values are 475 nanometer, 520 nanometer, and 530 nanometer, respectively. The percentage of discrepancy were calculated, and the discrepancy obtained for the first, second, and third line are 13.37%, 1%, and 2.34%. From the values of discrepancy obtained, experimental values for second and third line are accepted since the discrepancies are lower than 10%, while the experimental value for the first line is rejected because the discrepancy is higher than 10%. Next, for cadmium vapor light, the wavelength of the colors in the spectrum obtained are 609.24 nanometer, 628.14 nanometer, and 820.38 nanometer, while the theoretical values are 445 nanometer, 520 nanometer, and 530 nanometer. The percentage of discrepancy for cadmium vapor light are 36.91%, 20.74%, and 54.78% for the first, second, and third spectral line respectively. From the values of discrepancy obtained, all experimental values are rejected since the discrepancies are too large and more than 10%. The deviation of experimental values from theoretical values are due to several errors that might occur when the experiment was conducted. One of the errors is systematic errors such as poorly calibrated instruments that causing the reading of the intestine not accurate. Secondly, random error as the light source were not let to warm up for a sufficient time before the experiment was started. Thirdly, another random error as the light photon from the surroundings are also detected by the light sensor that lead to inaccurate data reading. For the conclusion, the wavelength of the colors in the spectrum of a mercury vapor light determined are 411.5 nanometer, 514.82 nanometer, and 542.4 nanometer for the first, second, and third spectral line respectively. Then for cadmium vapor light, the wavelength of the colors determined are 609.24 nanometer, 628.14 nanometer, and 820.38 nanometer respectively.